When it comes to soldering, over the last few months, I seem to have been encountering more and more issues. Which begs the question, is it me or is it the tools? A while back I bought myself a hot air and soldering station and I did a bit of a review on it and I said just how fantastic it was. So what's changed? You'd expect with more and more practice that I've got better at soldering. So the temptation is to blame the equipment. But as they say, a poor workman blames his tools. So I'll take you through my setup and what I think has been causing my problems. So if you're new to soldering, hopefully you'll learn something along the way from this. And if you're an expert, you'll be able to burn me up in the comments. But hopefully likewise as well, support me and put some useful comments in to help me improve. That said, a quick thank you to the sponsor of this video, PCB Way. Hey, big shout out and thank you to PCB Way for sponsoring this video on my channel. PCB Way, they make PCBs from as little as $5 with super fast shipping. Here is one that I got off their project pages. It's a recreation of the issue 3B ZX Spectrum board. So if you fancy getting yourself one of these, get yourself on the PCB Way projects pages. But not only do they do PCBs, they also do 3D printing. This is a little case they made up for me for my little Retrolium diagnostic cart. And as well as 3D printing, they do CNC machining. So whatever your project needs, do check out PCB Way. If you need some inspiration, check out their project pages. It's crammed full of them. But thank you again to PCB Way for sponsoring this video. Link in the description. Now this is my daily driver, the Hua 968 DA Plus 3. And I'm not going to talk a great deal about it, other than the reason I got it is it's got a 60-watt soldering iron with a smoke extractor built in, which you can toggle on and off. Variable temperature range, which bob it on, turn the smoke extractor off so we're not getting the noise from that. And it's a 60-watt iron and it's got a usable range from 200 all the way up to 480. And the reason I got this is because I wanted to have the hot air wand as well. And rather than having separate units, I thought, why not get it all in one? And if you've watched my previous video on it, I loved it. It's absolutely brilliant. But in recent months, I've just found the performance hasn't been there. And I'll try and show you what I mean by that. When I started out with this machine, I always had it set to there or thereabouts 330 degrees, which was a good balance between getting the solder joint hot and melted, as opposed to turning it up too high and risking causing damage to either the board or just wearing out the soldering tip and oxidizing it prematurely. But I found myself over time turning it up and turning it up and turning it up and turning it up till I was regularly desoldering soldering at 390, sometimes 400 degrees, which isn't right. As a result of turning the temperature up, I did start running into a few problems, and one of those was the tips just kept oxidizing constantly. And just wearing out to the point where I just couldn't keep on top of them. And I've regularly been buying cheap tips off eBay to try and resolve it. Now this is a little selection of tips that I have been using. Some of them do need, try to get on camera. Some of them are in need of a really, really good clean. You can see all the black oxidization on it. And the other ones are just sat there with a bit of solder on to stop them oxidizing as they're left unused for periods of time. And me being me and working to a budget, I buy myself the cheap stuff off eBay. 2 reasons. Number one, I'm not sure it's worth spending the money on more expensive stuff. And B, everything I do is I'm just trying to work to a budget. The other thing that I've been considering as a potential issue is this cheap solder wire that I buy. And once again, I buy it just because it's cheap. And I'm wondering how the issues that might be caused using cheap solder wire. And one thing that I've noticed in using the cheap stuff is that the amount of flux inside is pretty limited, which is why I always like to use plenty of additional flux to assist making the good joints. I discounted this as being part of the problem because I've always used cheap Chinese solder wire. And if that's not changed, then this might be making my soldering harder, but it's certainly not why it's causing me to see a drop-off in performance. So I discounted the solder wire as being an issue for me. Now, before I got that all-in-one unit with the hot air and the soldering iron, I was using this, which once again is a 60-watt iron. Nothing special about it at all. Super cheap with a variable temperature setting. I think this one, similar temperature range, 200 to 480 degrees centigrade. And so I thought, right, let's give this a try. And working on the same joints, this one worked perfectly. I'm like, what is going on? So I thought, right, let's start to eliminate a few things. So I took the tip off this one, which, if you're not familiar with soldering irons, they just unscrew. There we go, that's moving. So easy enough to swap around. There's the heating element inside, there's the tip. Jobs are good done. And I'll swap the tips over. So I took the tip off my newer soldering station and put it onto here. And I instantly had the same problem with this. So I'm like, right, has to be the tip. But why? Now, the cheap tips I've been buying off eBay, generic and not specific to a particular soldering iron or manufacturer's soldering iron. And this is one of them here. Most of them, the tips I was looking for them, but I think I've thrown them away now. And it might be difficult to show on camera, but I'll do my best. And there is quite a lot of wiggle between the actual heating element, the ceramic part, and the tip itself. Quite loose. And when I put an original one that came with the machine back on, lo and behold, a much tighter fit. Now, what I'm thinking here, and I might be wrong, and you experts out there do let us all know for sure, but my thought process is here is that obviously the heat is generated in the ceramic element and gets transferred to the tip. And if this gap is too big, then the amount of heat transfer to the tip is going to be reduced. You want a reasonable amount of contact between the tip and the element, and that's going to give you the best throughput of heat from the element into the tip. That's my theory there, because putting on, I think this is a genuine one, it's a little bit loose. It's not a snug fit, but the difference, the wiggle is a lot less. And I think that has been what's caused me an issue. Because what I did do, I'll just be careful because I don't want to knock the ceramic. What I did do was I went and bought myself some genuine Yahoo tips, and Since using these, performance has been drastically improved. But then I've found out the performance still deteriorated, which I couldn't understand. Now, another thing that I have done is I've moved from the type of tip that I've been using. You see here it's I think they call it a wedge shape. So you've got a flattening off end with sort of like, or is it a chisel tip? I don't know, but it's that shape anyway. I've started using that because before that I was using these conical ones, which is probably what you find has come with your soldering iron, which are fine, but as I've started to understand soldering a little bit more, the smaller the tip, the easier it is to get in there, but likewise, the less thermal mass it has. So when you're starting to work on joints, especially if the joints are a bit bigger, you struggle to get enough heat into them. So that's why I've moved on to this, which has been like night and day in terms of overall performance. Just focus the camera in. That to me is a really good tip. It's a compromise between something being too big but having loads of thermal mass and something being a lot smaller. What works for you, but for the vast majority of soldering, that works really well for me. Obviously, you're going to be working on really big junctions or something, then you probably want a much bigger tip than that so you can get the heat into it. But that has been a big improvement for me too. So I'm pleased with that. But as you can see, it's not as shiny as what it could be. There's still an element of oxidation. So I'll give that a bit of a clean. And I do need another sponge. Let's come and clean air. Let's see what it's like with the solder on it. It still needs a bit of a clean. Just wait for the heat to come back into it. I'll turn it down as well. Let's just turn it up. 330. See how the solder clings to this. Yeah, it doesn't really want to. Still needs a good clean. What I've learned as I've been going along is when it comes to soldering, let's get some of my wool as well. Cleanliness is next to godliness, and this is something that I haven't truly appreciated as I've started soldering. Clean joints, clean iron, clean tip. It makes a difference between having a really bad day out, that's starting to improve now, and really struggling with your soldering and actually finding it really easy and doing a good job. It's getting nice and shiny now, and that should just wait for the tip to warm back up again. That should take the solder really nicely. Which it is doing. It's a bit of a clean. There we go. Perfect. Ready to go again nicely. So I've just got one of my old scrap boards out. It's a ZX Spectrum board that's total scrap. What I truly hadn't appreciated starting to solder is just how important a clean tip is, because as soon as that oxide layer starts to form, or there's old burnt solder on it, that heat transfer from the end of the tip to the board, to the component you're trying to solder, is absolutely destroyed. It makes such a difference in terms of the heat transfer, having a clean tip to having a dirty tip. And I didn't really truly appreciate it. And whilst I can't show you the difference because this is a clean tip now, and some people advocate to just put a bit of solder onto the tip before you do a joint, just because it increases the contact point of the component you're going to solder. I'm not soldering anything new on But if we just go to that component there, you can see it just melts instantly. Made a bit of a mess there because it's because there's too much solder on it now. I'm not soldering anything on there, but you get the idea. It makes such a huge difference, and if we wanted to put more on, we could do, and make it into a ridiculously huge blob of solder. Let's pick something else. So that's, once again, these are already soldered. Let's go in and melt it if we can. So this is set to 330 degrees. You see the joint bubbling away. If we needed to add more solder onto it, off we go. It's as easy as that. But the difference between doing it like this and doing it with a tip that's got oxidation on it is night and day. Like I say, don't worry about the fact that there's loads of solder on there. I'm not teaching you how to solder. I'm just showing you, even at 330 degrees, really simple. The things that we might struggle with at 330 degrees, the 60-watt iron, is some of these big connectors up here. But we'll see how we get on. Give time for the heat to get into it. As always, you want to be touching the leg so that the heat transfers into the component leg as well. It's bubbling away. They're going to let us put some more on if we wanted to. Yeah, the joint's all nice and liquid. In fact, for that, I'd probably just turn it up, maybe a fraction more. There's the 60-watt iron on these bigger joints. May just want a little bit more heat putting in, but even at 330 degrees, it's doing the job there, isn't it? It's melting the joints nicely. The difference of having a clean tip. Is this one going to go? Yeah, the heat's moving through the joint, isn't it? Going liquid. Yeah. I mean, some people say when they're soldering, it's better to use a higher heat for a shorter period of time. You do what you think's best for you, but I've not had any issues using lower temperatures. The other things I'd struggle with is like, see all this green bit on the board here, where there's a large ground trace, and I think there's a little component leg in there. Let's see if we can melt this. Because the ground traces, just these big traces, just suck the heat away. And this is where, on occasion, you might just want to turn on. Oh, it's melting the joint. See, it's all a bit. You can describe it. It's not fully melted the joint, has it? Let's see if we can keep the heat on a little bit. This is where, even with a clean tip, I'd probably turn the heat up. In fact, I'll do that just to. So I've turned that up to 370. Let's see how we get on there. Let's give it a few seconds to warm up. Give that tip another clean. Nice and shiny again. Just bob a bit of solder on once it warms up. You can see that melting through the joint nicely. The other thing that I've learned, and this will make you experienced solderers laugh, I am sure, but I'm here to entertain, aren't I? I've actually never used a sponge until relatively recently. I always used this to clean the tip. I thought this would always do a much better job than the sponge, but that is not the case. The sponge is absolutely brilliant. Obviously, it's soaked in water. The sponge is absolutely brilliant for cleaning the tip. There you see there, it's nice and shiny. I just never saw the point of the sponge. I know I can hear you all laughing and going, "What are you talking about, Simon, you big idiot?" And yeah, that's naivety for you. I would just literally use the copper stuff to clean it. And I think that might be why I always struggled cleaning it and getting it nice and shiny. There's, I don't know if the water on the sponge helps thermally shock it to help clear it off, but the sponge is absolutely brilliant. So if you're an idiot like me and you're starting out soldering and you just think, yeah, whatever, this is the best thing you've got to clean your tip by miles. That's from my experience anyway. Your mileage may vary. If you watch my recent upload, this is a ZX Spectrum board I'm starting to build, and I wasn't happy with some of the joints that I did on that, just primarily because I'd used too much solder on some of the joints. Well, if not all of them, to be fair. Less is more when it comes to solder, really, I think is a general rule of thumb from the advice that I've been given anyway. But I think that was down to user error more than the equipment. In fact, I don't think there was any issue with the equipment whatsoever. And I think that was just struggling to see what I was doing because I've got the camera in front of me as a film and I can't get nice and close up as I would do if I wasn't filming. So I think what I will try and do is, now that I seem to have resolved my soldering issues, is I'll try and film from a different angle so that you still get the best view, but I can still get close up and see what I'm doing. And if you're interested in an update for the Spectrum, I will be doing another part of the build soon. I've got loads and bits and pieces. I'll just show you briefly. This little jiffy bag here, I'm not going to open it now, but one of my subscribers, James, very kindly sent me this in. I will show you what he sent me in the next Spectrum build. And I've also had this sent to me by John, this substantial box here. There's lots of goodies in there in relation to Spectrum and some other bits and pieces. So if you want to see what James and John have very kindly sent me, then keep an eye out for the next update on my Spectrum build. And also thank you to John Lee Pettimore III, who very kindly sends me money from time to time. He buys me a coffee. There is a link in the description if you would like to support me. It makes all the difference and it's always very much appreciated. I'm certainly no expert, but I hope you found that useful in the problems that I've been encountering. My advice would be, don't buy cheap tips. Buy the ones made by the manufacturer for your machine. And beyond that, make sure that you keep your work clean and your tips especially. I just couldn't believe what a difference it makes, but it really does make a huge difference. And who would have thought using a wet sponge, but there you go. Use a wet sponge. If you like that, don't forget to give me a thumbs up. And if you want to see more, don't forget to subscribe. That is more than appreciated. My next video that I've got planned is I'll be continuing the build with the ZX Spectrum. Lots and lots of bits to start continuing that build. So I hope you'll join me for that. Thank you for watching. Hope I'll see you again soon for that. In the meantime, bye for now.